Okay, good morning, afternoon, or evening, everybody. Welcome to the Access NASA GES DISC Meteorological and Hydrological Data for Flood Analyses Earth Data webinar. This is your host, Jennifer Brennan. It is 2 p.m. Eastern Daylight Savings Time, and so we are going to go ahead and get started here. What I'll do first is I will begin today's webinar with a few logistics. To ensure the best audio experience, all participants have been placed in silent mode. So if you have any issues or you have any questions, please enter them into the Q&A panel rather than the chat, and that you can find on the right side of your screen. Today's webinar is being recorded. The recording will be posted both to the NASA Earth Data website and also to our NASA Earth Data YouTube channel within a week of completion. Once completed, what I will do is I'll send an email to all registrants, and that email will include a link to the recording and also a link to the presentation slide deck that is used within today's webinar. As far as timing is concerned, today's webinar will be 1 hour and 15 minutes long. It might be a little bit shorter depending on the questions that are received, with 1 hour allocated to the presentation and demonstrations and the initial Q&A session, with an additional 15 minutes, worked in there for an extended Q&A period. During today's webinar, we will have 2 speakers and 2 Q&A panelists. Our first speaker is Dr. James Acker. Dr. Acker is a support scientist at NASA's Goddard Earth Sciences Data and Information Services Center, or GES DISC. He will begin today's webinar with an introduction to floods and flood modes. And with that, why don't I go ahead and pull up the agenda really quickly. The floods and flood modes, and also provide an overview of how you can study flood modes using data from the GES DISC. Our second speaker is Chris Battisto. He's a scientific developer and AWS certified solutions architect, also at the Goddard DAC. He will walk you through a Jupyter Notebook-based data use case study for flooding in Brisbane, Australia. After this, we will transition back to Dr. Acker, who will provide information about GES DISC resources for data and analysis, and that will also include data variable tables by source. Once Dr. Acker is finished with his presentation, what we'll do next is we will transition to an optional final set of polls. I'll give these questions probably about 5 minutes within the webinar time period before we move to the Q&A session. But what I'll do is I'll leave the questions open much longer for those of you who would like to provide feedback as we're going through Q&A. From there, we'll jump directly to the Q&A period. And again, we will extend the Q&A period an additional 15 minutes from end time for those of you who wish to stay on the line, but we will have a hard cutoff of 3:15 p.m. We have 2 Q&A panelists for this afternoon session, Dr. Benita KC, who is the user needs lead for the GES DISC, and Alexis Hunzinger, who is a scientific software developer at GES DISC. Just a final note about the Q&A, we will try to address all the questions within the time allotted, but if we're not able to address your question during Q&A, know that I will be sending our speakers the Q&A log so that they may follow up with you offline. With that, it is my pleasure to introduce today's first speaker, Dr. James Acker. And at this point, I am going to stop sharing my screen and toss the presenter role down to Jim so he can get started here. Give me one moment here, if you would. All right, Jim, you should have presenter privileges at this point. You'll have to unmute yourself if you're not already.
Can you hear me?
I can.
Okay.
Very good. Thank you.
Okay. Well, as Jennifer said, we're talking today about floods, and the title of our presentation is Accessing NASA.
So, Jim, before we get too far in, you do sound a little bit far away right now. If you could maybe adjust your audio.
Closer. How's that?
That is better. Yes.
Okay. Thank you. Anyways, the title of our presentation is Accessing NASA GES DISC Data for Flood Analyses. You can see the authors that have been mentioned already and who we are at NASA Goddard Earth Sciences Data and Information Services Center. And the image here is of a event that has been in the news and actually continues to be in the news. Some floods that occurred in Pakistan. This is off of the Indus River. It's a Landsat 9 image that was featured in an Earth Observatory article in late August. And I noted that there's another Earth Observatory article about this flood event and the rains associated with it, dated October 13th on the Earth Observatory. So this is something that is definitely in the news and won't stop being in the news. Okay, so why are floods studied? And floods are likely the most dangerous weather-related hazard known in terms of the endangerment to human lives, the loss and destruction of land and property, and economic damage to infrastructure, and I should also add agriculture. Floods are caused by different combinations of global and regional climate, geography, and weather. Floods can be studied, therefore, using hydrological, meteorological, and socioeconomic variables, which allows insight into how they're caused, the effects of them, and very importantly, informing post-disaster assessments to try and prevent either their damage or their occurrence in the future. We know about floods that they are likely increasing in both severity and in frequency due to climate change. And this is also increasingly impacting vulnerable populations, which live near rivers, live near coasts of oceans and lakes, and live near mountains, where you can get flash floods and landslides. Talk more about that in a moment. Okay, so I'm going to talk about the flood modes. And there's really three basic modes. And the first one is seasonal flooding. And this is one that can cover a very wide scale over a large region, over a full watershed of one or more rivers, and therefore it's associated with rivers and lakes. Lakes can overflow as water flows into them. Rivers obviously can jump their banks. And this can take place over weeks and even on a scale of months. And that's because the causes of these is generally seasonal change. And when we say that, it usually means what happens in spring. It warms up in spring, ice and snow will melt, the soils will get saturated by this amount of water, and also the plants are not available to pull moisture, water out of the soil. So evapotranspiration is important. And then aggravating factors are erosion. Water can run off quicker. Canalization, the rivers not following their normal patterns and have floodplains will jump the rivers into where people live, jump their banks, sorry. And climate change. Spring is shifting, becoming warmer earlier, becoming warmer faster. And we're also seeing heavier precipitation in many places in winter, and that provides a bigger snowpack, i.e. more to melt and contribute to the flood in spring. And here we have an image of comparison of images in 2018 and 2019. And in 2019, there was severe flooding in the U.S. Midwest. And this shows the Missouri River near Offutt Air Force Base, which is south of Omaha, Nebraska. And you could see the widespread flooding that occurred on this date. This was a very interesting situation. It was partly caused by heavy snow melting and also caused by a storm that put a lot of precipitation on still frozen areas. And that caused a lot of this flooding. And we wrote an article about it, which is linked here, that you can see a full analysis. Okay, the second flood mode is coastal flooding. This will be, excuse me, a somewhat smaller region, so can cover a wide area, and usually means land adjacent coasts. Therefore, it's associated with ocean, bays, and even large lakes. The temporal duration tends to be shorter than regional flooding, so over a period of days to weeks. And the causes tend to be large storm systems, tropical storms, hurricanes, nor'easters, monsoons, which can also get coastal flooding from high or king tides, and even a seiche, which is a sudden rise of water level in a lake as the water flows from one side to the other. Aggravating factors are sea level rise, coastal subsidence, lowering of ground next to the coast, and climate change. More intense storms are occurring. Storm tracks appear to be changing in some cases, putting a hurricane overland, and it will linger there, as happened in Houston. And coastal infrastructure. You have more structures there that can move water around and which can be knocked down. And this shows a picture of coastal flooding from Hurricane Florence on the North Carolina coast. Another article that we wrote, which is available on our website, analyzed this, and you can see some really dark areas where a lot of the floodwaters from Florence were hitting the water bodies near the coast, and you can also see some definite outflow effects as this water made its way to the ocean. And the third mode is flash floods. These tend to happen in a smaller area than the previous two. Cities, counties, valleys are definitely important. They are associated with streams. They can be associated with dry riverbeds or arroyos, which can carry water, and they can carry water down from the mountains. Flash floods can happen when it rains many miles away from where the flash flood happens, such as rains occurring over the mountains, goes into the streams, and comes rushing down into a city or two. They happen very quickly. They happen over hours, maybe a period of days. They're associated with severe storms, monsoon rains. They can be associated with landslides, which can break natural dams. Volcanic activity can trigger mudslides or lahars. And you can have failures of both natural, like an ice dam of a glacier, or an artificial. Aggravating factors are impermeable surfaces, such as you find in cities, concrete sidewalks and asphalt roads, inadequate infrastructure. Storm drains cannot handle all the water. Geography is really important. A valley can concentrate a flash flood. And heavier rainfall. We're seeing that happen. Definitely a trend in increasing rainfall, extreme events, glacial melt happening, and as I said before, geography. These images show an event that happened in June of 2020, which Benita KC, one of our Q&A panelists, analyzed for a federal GIS conference. It shows heavy rain in Massachusetts. Using GIS, you can plot out the areas of hospitals. And Norwood Hospital, which is the red dot, was hit very hard by the flash flood. And you can see the flash flood entering the emergency room doors, clearly an emergency, as this event took place. Okay, so now I'm going to talk about our resources. And very quickly, I'm just going to mention the acronyms that you will see mentioned in the upcoming slides. You can read what the acronyms mean, but we're going to be talking about IMERGE, GPCP, Meritu, and both GLDAS and NLDAS. These are the main data sets that can be acquired from the GES DISC to look at flood events. And we also have a merged IR data set, which allows you to look at cloud top temperatures. And you can also see storm systems evolve that way. You can also see ash clouds from volcanoes. GLDAS and NLDAS have a very large variety of hydrological data variables. This includes runoff, surface and subsurface, soil moisture, snow depth, snow melt, evaporation, and evapotranspiration. So these are good go-to data sets. Okay, so now I'm going to talk about the characteristics of the data and which variables can match up with each of the flood modes. So for the first flood mode, seasonal flooding, as I said, the temporal resolution does not have to be as high because these take place over monthly periods, so you can look at monthly data, data which is averaged over a monthly period. People ask what monthly data is, or daily data. Okay, the aerial coverage should be large, covers regions and continents. Okay, and the time period, well, it happens every year. It's associated with spring, and you can see changes over decades. And I'm going to talk about all of these. You can look at trends with longer term data, which means over a decadal, on a decadal. So what are we going to look at for that? Obviously precipitation, rainfall, snow, the snow depth and the snow melt. Definitely runoff, how much runoff is occurring in the spring, and the soil parameters such as soil moisture, surface temperatures, ground temperatures, and evaporation. Okay, and I have a picture here taken by an astronaut of an area which is affected by global warming, Greenland, and you can see a glacial river flood, and you can see that is right next to an airport. And we've seen other airports that can be affected by floods. So floods and human infrastructure don't always get along. This is a table that shows all of the data sets that are the monthly scale. Okay, so this is all monthly data products from the previously mentioned data sets, And all the links in the presentation, which will be available after our talk, are linked to these actual data products. You can get the monthly data variables. Okay, the second flood mode, coastal flooding. Tends to occur on a smaller, shorter time scale than seasonal flooding. So we think that the best temporal resolution would be daily data. Again, regional, storms can cover a large area, but down to local. If you're really looking at local effects, particular beaches, cities that can get flooded. So you can use time period of annual. You might want to look at 1 month when a storm or event is occurring, but again, you can use it for trend analysis, see if there are more floods occurring on the coast. Data variables, again, precipitation, but here in this case, we're also going to add in wind speed and wind direction, because the wind's blowing in a certain direction will blow the water on the land, as we have just seen with Hurricane Ian driving a storm surge onto the coast of Florida. Okay. And also soil moisture, again, saturated soils will cause more floods because the ground can only hold so much water. Surface temperature and humidity or precipitable water vapor in the atmosphere contributes to the amount of rainfall that can come from an event. One of the most famous storms that we've seen is Hurricane Sandy. It's one that we can analyze with a lot of the data we have. This is a geostationary image of Sandy, and as we know, this had a pretty severe impact on New York City and areas near that, becoming one of the most expensive storms in U.S. history. And here are our daily data products. Again, you'll see our data set names, but the links will go to data variables that are available at daily time resolution. You'll also see on this chart what the spatial resolution is. And in many cases, it's down to 1/10 of a degree, which is really good for looking at fairly local effects. The third flood mode is flash flood. Okay, these happen fast, as we've said before. So you want daily data or sub-daily. We have 3-hourly data products, hourly, and even half-hourly data products. The scale tends to be smaller, so you're looking at small regions, watershed scale in a river, and local in a city. And the time period it can occur over months. It can be a very rainy month, can cause flash floods. Daily, you can look at these occurring in daily or even sub-daily. And decadal, you can look at trend. You can look at trends in them as they are happening. Extreme events, as I've said before, are definitely extreme events are actually increasing, and that's in many parts of the world. Our data variables: precipitation, both rainfall and accumulated rainfall, wind speed and wind direction, because they are generally weather associated events, soil moisture, surface temperature, humidity. Geographically speaking, you can also try and look at elevation and impermeable surfaces. It's also available. Those are not data types that we have, but our associated DACs do have those. Our image shows an event that happened in 2021, which caused heavy rain and flash floods in London that actually caused damage with some very expensive basements in the city of London. What was interesting about it was not as much rain fell in London itself as did on the coast, but because London is a big city, lots of impermeable surfaces and antiquated storm systems to handle the rain, the flash floods happened there. And here is a table of the data variables and data sets for which we have hourly, half-hourly, and 3-hourly data. You can notice one thing in particular: the NLDAS, which is for North America, is available in hourly resolution. The global data, GLDAS, is available at 3-hourly resolution. So we don't have an hourly data set for the entire world in this case. Okay. I'd like to introduce what we're going to talk about next, which was some floods that occurred in Brisbane, Australia in February of this year. And this was an interesting event where the atmospheric circulation set up such that very moist air coming off from the tropical seas north of Australia moved into a circulation pattern that took it over the east coast of Australia. Okay, and this map was created to forecast what was about to happen on February 25th. We have an article about this where we looked at the precipitation that occurred, and we're going to look at it in a more detailed way with the data that's available from the GES DISC. Okay, just to talk about a little more what happened as this atmospheric water vapor moved in, caused a series of storms that basically formed what meteorologists call a train, storm after storm after storm for several days. And this inundated the area, caused rivers to rise several feet. And a little bit later, after they had flooded Brisbane, the system somewhat eased to the south and caused some flooding in Sydney. Just a note in the chart, the darker colors indicate more water. You can see it was carried definitely right over the east coast of Australia. So now I'm going to stop sharing and actually I think Jennifer can switch me and we'll go to Chris, who will take over from here.
Okay, Chris, you should have presenter capabilities at this point.
All right, can everyone hear me?
We can.
Excellent. Well, thank you for our quick rundown of our different products towards studying events like this. My name is Chris Battisto. I am a scientific developer here at the GES DISC. And what I'm going to do is walk through studying other precipitation events like this by specifically talking about some of the services that we offer. But what I'm going to do is dissect a little bit more of what happened during this Brisbane flood event and talk about that through the lens of open science and how we can use that data to learn more about it and potentially others. So this Brisbane flood event took 20 lives across Queensland and New South Wales. And according to the Australian Bureau of Statistics, by the end of March of 2022, as part of a long 12-year increase in this trend, there were about 15 billion Australian dollars of non-life insurance claims reported from just the Southeast Queensland and New South Wales flooding events. And so our data center understands this demand to study events like this using our data. And what we can do is provide publicly available services to access these and even restructure data sets like these for different communities that wish to study these, right? Because you can understand that with an increasing trend like this, are these events part of a long-term trend being caused by climate change, maybe varying land use patterns? Fortunately, we do provide services that allow you to access long-term data like this efficiently and in a way that prevents barriers and contributes to open science. And so what I'm going to be showing during my demo here is one of these services, which uses some of this data that Jim previously showed. And that is our hydrology data rods time series subsetting service. And so let's say you wanted to look at years and years of this LDAS data. You wanted to look at a particular variable only at a single grid point, and you wanted to make a time series of that. Now, before, what you would have to do is subset those variables, the lat-long extent, and you would still have to download those files at one time step per file. So you can imagine that with a data set that has a 3-hourly time dimension, that adds up quickly over time. And so instead, what we've created is this data rods service where we organize those variables into what are called data rods, which is essentially what they resemble, at one grid point at all time steps per file. And so if you know the variable that you want to look at, the lat-long of the single grid, and the length of time that you want to look at, you can query one of these data rods, and you can retrieve all of that data in remarkably fast times. So one of the services that we offer is we can create plots in your browser. And this plot on the bottom left here of this image is one of those sample plots. That's 320,000 time steps plotted in about a second. So this is a very powerful service that we offer and is something that is pretty much available to anyone who accesses our website. So where can you find this data rod service? I've got it linked up here in the title, but we can also drop the link for it in the chat. On our home page, we have it linked under Data Rods for Hydrology inside of this Tools section along some of our other services that we have. And when you click on that link, you're met with a page that describes this Data Rods time series service and gives you a table which presents all of the different data sets that are organized into these data rods, their metadata, and two links. One of them creates a sample plot and the other returns ASCII text data of that actual variable. And these links on this page offer sample plots, but these are essentially hyperlinks that point to the time series API, which takes a key value pair syntax of the lat-long grid that you want, the time length, and the variable that you want. And so let's say if you wanted to look at rain precipitation rate, you can click on either of these hyperlinks, make plots that I showed in the previous slide, for example, or you can download the data as an ASCII file once you can manipulate those links. And so that's great, but we've got other tools available to us just besides accessing this from a browser. So what if I wanted to access this time series data service and I wanted to use a widely supported data service or data analysis language like Python? And I wanted to create a statistical analysis of this, maybe some climatologies, and plots of this using libraries like Matplotlib to create a climatology of some of these hydrology variables and give some more insight into events like what happened in Brisbane of this year. What you can do is use Python to query the hydrology data rods API. And so that's exactly what I'm about to demonstrate to you in a Jupyter Notebook. What I'm going to do is generate a time series over that Brisbane grid. I'm going to create a climatology of total precipitation rate. And what I'm going to do that is query that total precipitation rate variable from the data rod service using some built-in and third-party Python libraries. And I'm going to have a time query from June 2012 to the end of May 2022. Once I know the time, the location, and the variables that I want, I'm going to pass those to the API link. I'm going to extract that time series data in ASCII format. ASCII is basically the data returned to you in a text format. And I'm going to stick those inside of a pandas data frame and do some plotting with Matplotlib. Pandas is essentially a data analysis library that you can use in Matplotlib, and Seaborn are used to create various plots. So I have a recording of this Jupyter Notebook. This is my Jupyter Notebook setup running in Visual Studio Code. For those of you who are not familiar with Jupyter Notebooks, they're essentially a way to organize both Markdown and working Python code into a single document. So you can have cells of Python code. They can output things like plots or pandas data frames. And then you can describe those inside of the same document with Markdown. And you can share this with others to run in their own Python environments. And so what I do here is describe what this notebook's purpose is. What I'm going to do is query a grid over Brisbane, and I'm going to look at 10 years of 3 hourly total precipitation rate data. Then I'm going to sum those 3 hourly total precipitation rates up, convert them into millimeters per day. I'm going to calculate their monthly means and then create a monthly z-score of those to try to identify any anomalous precipitation events, such as our event in Queensland, New South Wales. So the first thing I do is I import my modules, which is in this first cell below. And then what I'm going to do is define two different functions, which calls that data rods service, returns the data in an ASCII format, and then puts them into a pandas data frame. So this first function I have here is called getTimeSeries. I pass in the variable that I want, the data type that I want. You could also get some of these data back in NetCDF. I also pass in the location, which will return a grid closest to that lat lon that I query. And then I have my starting and ending date for the time series that I wish to produce. I perform some other Python methods to check that the link is working and active, and then I return that as a text. Then I have a second function called parse time series, where I will parse that response from the data rod service and put them into a pandas data frame. So that requires a little bit of manipulation because it is an ASCII format. But what I can do is parse those key value pairs and put them into a pandas data frame, which will allow me to load it in memory and not download a single file before having to put them into the pandas data frame. And so this next cell is where that magic happens with the speed performance that we have. Now, something to note is that this variable that we have, this rainf underscore f underscore TAVG, the total precipitation rate, is a variable that is actually sitting inside of the AWS cloud. And as a result, we experience an improvement in speed for querying this data. And we also have more scalability. What we're in the process of doing is migrating some of these other variables to cloud as well. And so with this, I can show you off some of that speed. So what happens is I define my functions, I load them into memory, and I pass in the start and the end date that I want, along with the latitude, longitude, and variable. And I'm going to click this little play button to the left of the cell, which runs the cell. Visual Studio Code gives you the length of time that these cells take to run. I print out the link just for diagnostic purposes, and in 8.7 seconds, I have retrieved 29,000 rows of 3-hourly GLDAS data over this Brisbane grid. And the functions that I defined, put them into a pandas data frame. Lickety split. And so you can imagine applying this towards multiple variables. You could even query multiple grids, maybe even make an animation. But it is important to note that this is primarily for querying specific grids that you want, especially because we're looking at data sets like GLDAS, which are on a quarter degree by quarter degree, very fine scale resolution. And so with that, what I'm then going to do is take that pandas data frame. I'm going to calculate and aggregate my daily sum, convert them to millimeters of precipitation, and then resample the monthly means of those. And then I'm going to create a plot that is similar to the plot that we will generate for you, but I'm also going to add a monthly average line. And so this is the type of plot that I wind up with. This is using a seaborne theme, and you can identify various high precipitation daily events throughout the last 10 years, going up to the end of 2021 and into 2022, where you see this increase in monthly average daily precipitation. Well, that's great, but how does that translate into the climatology of precipitation? Looks like I skipped back a little bit there. Now, I'm not going to go too much into detail of the various pandas functions involved to calculate this, but what I can do is iterate through that original data frame. I can add a year and a month column to those to allow us to subset those and aggregate those on different timescales. And then what I can do, similar to what you would do in Microsoft Excel, is create a pivot table where I aggregate those daily sum values by month. And I can wind up with a pivot table that looks like this. And then what I can do is use pandas to calculate 10-year monthly z-scores of that total precipitation for a Brisbane grid. So I iterate through and compare each month to the 10-year month z-score for that. And then I can use a seaborne heat map to create a plot like this, where I look at the different monthly z-scores of total precipitation in that Brisbane grid for the last 10 years of 2012 to 2022 data. And so I can identify anomalously high monthly precipitation events. And if we look at this from the standpoint of our 2022 floods in Australia, you can see that they had consistently higher than average precipitation by month. And even up to May, we did have very anomalously high precipitation compared to the last 10 years. And so the whole point of this exercise is to show you that just in under about 2 minutes, give or take about 30 seconds for iterating through the pandas data frame, what I was able to do is query 29,000 time steps from this data rod series, put them into a Jupyter Notebook, and create open science that can give us more insight into these devastating flood impacts by creating a climatology. And so we will be glad to share this Jupyter Notebook if you wish to run it on your own. You can play around with different variables, different grid points, different time series. We can put that link in the chat. At this point, I'll go ahead and drive for Jim. I'll drive the slides for Jim, but I will hand it over to you, Jim.
Okay, thank you, Chris. Yeah, one thing I wanted to note too is as we were looking at this data, the spring period in February is a rainier period than May, but there was that really extensive anomalous rain in May. It's not as much rain as fell in February, but it's much more anomalous, which we found quite interesting. Anyways, the rest that we want to talk about is how you would get to our data and use some of the tools that we have available, both to tailor it to your needs and other ways to analyze it, at least to get started on analysis. Okay, so we provide access to numerous data sets. You've seen them listed here. We have to always specify that we have data directly from our satellites, our Earth observing instruments, and also models, and that's NLDAS, GeoDAS, MERA2 are models based on remote sensing data and other data inputs. Okay, so if you want to find the data, okay, and you have the links in this presentation, but if you want to come directly to our website and start looking around, you can type in keywords like precipitation or soil moisture, or you can type in a mission name like AIRS, the atmospheric infrared sounder, which also provides some data, or MODIS, things like that. GPM is our global precipitation measurement. But you might want to use the data set names. The corresponding precipitation data set to GPM, called the precipitation measurement, is IMERG, which you saw earlier, IMERG. Okay, now, also want to point out, we document everything for the use of researchers, so we have descriptive documentation for every data set. We have data set landing pages, which as you're searching, you will find links to those. Under the hood of this website, which looks nice and simple for ordering, is we also have other tools that some people are not initially aware of. We want to make you aware of them. You can go in, as you start to order data, you can use both temporal and spatial subset, and we can use it on the level 2 data. Level 2 data is at the satellite resolution, sometimes in a swath format, which you might have to work with further to average, but that also provides higher resolution than generally what we call the level 3 data products, which are on a global grid. We also have tools that allow for subsetting of the level 3, as well as regridding it if you're working with other types of data. We call that the level 3 regridder subset. When you order the data set, you will see the tools available as you're ordering them. Okay, next slide. This is our Giovanni system interface. You may have heard of Giovanni. If you haven't, Giovanni is the system that we have hosted for many years, and it provides access to numerous data variables, many of the ones that you've seen here. And in addition to providing access to the data in the level 3 form, we don't have a level 2 here, it provides analysis functions. And I'm showing what you would see if you click on the drop-down arrow under Select Plot. We have 22 different analysis functions. Okay, so in addition to subsetting the data and looking at it over a period of time, like a time series, you can make time average maps. You can average over different intervals. You can include shapefiles. We mentioned earlier that things like flash floods depend on watersheds. You can look at watershed scale precipitation using watershed shapefiles from major rivers. Okay, if you have an accumulated variable, such as accumulated rainfall, you can average accumulated rainfall over several periods. Okay, meteorologists make use of Hogmuller plots, and I mentioned AIRS, partly because AIRS provides vertical profiles of the atmosphere. So in addition to looking at spatial extent, you can look at what's happening in the atmosphere, where the water vapor is, and where the temperature might change, events related to weather that causes precipitation and floods. Okay, next slide. Now, right here, we'll show just a few tables, all of which will be available for download in this presentation slide deck afterwards. This is what you would get if you just searched on the keywords. You could click on this link, see all the IMERG data sets, see all of the GLDAS data sets, etc. And at the bottom, I just wanted to mention the merged IR that I had mentioned early in the presentation. You click on that, and that gives you access to the merged IR, which is available at several different temporal resolutions. Okay, next slide. Just a brief look at each of these tables, rather than sort them by temporal resolution. These are sorted by the actual data set itself. Okay, so here are the MERA2 data products that you can look at, and the different products. Some of the variables are listed in the third column from the left, and this also gives you the same information. And what's really important is you want to look at the temporal coverage. Okay, and where these begin. So in this case, MERA2 begins in 1980. We always like to say it's the beginning of the satellite era, was about 1979 to 1980. Okay, next slide. Here are all of the NLDAS and GLDAS collections, both hourly, monthly, 3-hourly, etc. And you can look in the column on the right. It gives you a list of all the different possible variables that you could look at in NLDAS and GLDAS. As we said, this is primarily hydrological data and very useful for looking at flood events. All right, next slide. Finally, this is IMERG and GPCP. It's a lot simpler in terms of variables because these are precipitation data sets. Okay, and GPCP is Global Precipitation Climatology product, so provide more of a climatological look at the data both from satellites and rain gauges. So it's a very comprehensive set that goes back to 1980. Okay, next slide. So that concludes what we wanted to talk about. We want to thank other colleagues that we have at the GES DISC, Jiahua Pan, Ashley Heath, Zhong Liu, and Christine Schmidt, who helped us put together the slides, the data sets, the tables, and gave us insight into all of the data sets we presented. Okay. And so I want to wish you a happy autumn if you're in the Northern Hemisphere, and a happy spring if you're in the Southern Hemisphere. And Jennifer will talk about the polls.
Okay, thank you so much, Jim. Thanks, everybody. At this point, I have opened up the optional final polls. We'll give these about 5 minutes here, and then we'll transition directly to the Q&A. So why don't we give these about 5 minutes? Thanks so much, but I will leave them open much longer so that if you are interested in providing feedback as we go through the Q&A session, you will have time to do so. All right, thanks so much, everybody. And just really quickly, as we are, I know there were a few participants who may have joined a little bit late after I had already covered some of the logistics information. And so I just wanted to mention one more time that after the webinar completion, I will send an email to all webinar registrants that will include a link to the recording, as well as a link to the presentation slide deck. And I will pull out some of the other links, the link to the Jupyter Notebook as well, and to the hydrology data rods. So if you missed that in the chat, or in response to a question asked by a participant, I will also send it out to all of you, and including any of your colleagues who may have missed this afternoon's event. So why don't we keep the polling questions another couple minutes, and then we'll jump directly to Q&A. You're quite welcome. Thank you so much. That's good feedback. Okay, and just as a reminder, if you have any questions, please type those into the Q&A panel, and you should see that on the right side of your screen rather than the chat so that everyone can see the question. That would be great, although I will scan both the chat and the Q&A for any questions. So why don't we go ahead and transition to Q&A now? And again, the polls will be open much longer. If you're interested in providing feedback, we certainly do appreciate it. The first question this afternoon is, could I have access? I think you had, I believe it was Jim, you'd mentioned a wiki page in the list of available data rods variables. And one of the participants is asking whether or not this page is publicly accessible.
Yeah, well, that was both Chris and I, but if you go to the homepage of the GES DISC, you'll see on on the bottom in the footer data rods for hydrology, and that's where you would access it. If you click that page, it will show you the variables that are listed. Is that right, Chris?
Oh, that would be correct.
Yes, and I can actually place the data rods link in the Q&A panel again. And I have done that a couple times, but I'm happy to do that again. Let's see, and I'm just scanning let's go scan through the Q&A. I addressed the sharing of the content and the presentation. Scanning for questions. Let's jump up to, I see there's a question in the Okay, so one of the, let's see here, is more of a comment. One of the users was indicating that she found the webinar quite useful. She primarily uses MATLAB and sometimes Python. I'll include that feedback in the polling question responses. If you received an error in the GitHub, let's see, one of the users is noting that they're receiving an error when accessing the GitHub page. The link, it says it does not contain the hydrology data rods time series / dem Jupyter Notebook path in main, but it looks as though the link is working on our end. Let me go ahead and paste that link again into the chat in just a moment, and let's transition to the next question. The next question is, can I send my geographic location to get information on rainfall data and geomorphological data?
Yeah, that's a great question. So for something like the DataRod's time series service, what you can definitely do is pass in that location and it will return the nearest grid closest to you. You just need to remember the structure of those data sets. So for example, the resolution of the grid. But that is a great use case for using our DataRod's time series service for retrieving things like precipitation variables.
Okay, wonderful. Thank you, Chris.
Let me ask,
Just,
I
go
think,
ahead. My apologies.
was asking about geomorphology data. That's not something that we have at the GS DISC, but our fellow DACs will have things, we'll have geomorphological data sets. The top two to go to for that are both the land processes DAC or LP DAC, and also I believe the CDAC, SEDAC. I think it has geomorphology and also human variables associated with that.
Okay, thank you very much. I'm just scanning to see whether or not there are any additional questions. I have provided a link to the Jupyter Notebook. If that particular participant is still having issues, please let me know accessing that. I've also added the LPDAC link to their website within the chat as well. Let's see here. Just looking to see whether or not I don't think I have missed any questions at this point. Just scanning one more time. Thank you.
There is
Okay.
a question on the JSON output format from Tommy Gomber. So do you want to take that?
Yeah, I see that question there. We do not offer JSON output instead of ASCII. We currently offer 2-column, 4-column ASCII, and then netcdf as part of the time series service, that is.
Okay, thank you very much. Let's see. Are there any additional questions? Anybody, if you have a question, please enter those. Yes, we do have another question. The next question is, do you need to authenticate your Python client, e.g. obtain a token first?
Fortunately for the time series service, you do not. All you need is an internet connection.
Okay, thank you, Chris. Let's see here. Are there any additional questions from anybody? Okay, the next question is, where do you get your evapotranspiration data from? Do you estimate it? If so, how?
I'll take that to start. I'm not sure of the actual algorithm for it, but that's in our documentation and can be pursued through our help desk or through the Earth Data Forum. But the actual data is in the LDAS, either the North American, the NLDAS, or the global.
Okay, thank you, Jim. Our next question is, are there any future plans to enable multiple downloads of time average maps via Giovanni? For example, downloading the monthly global BC from 2000 to 2012 at once.
Don't think we would have the batch download capability for that at this time. We are looking at one of our cloud migration strategies, which is something that's occurring over all the DACs, is to put all the data in the cloud. It may be enabled through the various interfaces as we actually move Giovanni functionality in the cloud. But at this point, I couldn't say for sure.
Okay, thank you, Jim.
If I may add to that, there is also a feature called animation feature using which you could also download these multiple maps.
Okay, thank you, Benita. Let's see, we have another question. The next question is, I'm interested in modeling urban floods that are caused by extreme rainfall and is not related to river runoff or coastal flooding. What types of satellite-derived precipitation data are there to model urban floods that need hourly, if not daily data, as well as fine spatial resolution? And I need it for Brazil that doesn't really have good ground measurements of precipitation.
Well, that is definitely our iMerge data products is the ones to use for that. Those are the precipitation data products. One thing we didn't go into, but briefly that there are three different kinds of iMerge data products called the early run, the late run, and the final. And the early run is provided early. It happens very quickly and is not as quality controlled. The late run is available a little bit later. Early run like 3 to 4 hours, late runs around 18 hours. That's been more refined. And then the final won't be available for a couple of months, and that is as refined as it gets. And so depending on the type of research you're doing, the three products would be, you'd have to evaluate the three products. Probably for what you're looking at, you want the final. And that's available at the best resolution that iMerge offers. And I'm definitely capable of looking at urban rainfall events because we did that in our London example, which is in our news article, which you can take a look at just as an example and take it from there.
Okay, thank you, Jim. The next question is, my apologies, I lost my place here. Okay. How do we convert, and I think you can use Panoply for this, and I'll put the link in the Q&A. How do we convert GRIB or NetCDF files into a working Excel model and make a time series?
Well, a couple of things. One, Panoply can do those things. If you make a time series with Giovanni, you can download it as a ASCII file, as a time. You will get it as month and data. If you're trying to convert a map, we have a how-to document on our website that allows you to use Giovanni, Panoply, and Excel together to turn it into a set of, you can see the values in ASCII format over here. Not sure if that answered the question.
Well, thank you very much, Jim. So what I have done is and I'll place the Giovanni link in the Q&A as well. I've added the Panoply link to so you can check it out. And that is currently in the Q&A panel. Let's see, I noticed there was another question and I want to scroll down here, or maybe I have covered them. Hold on one moment. Let's see. I'll need to scan back up in the chat.
Jennifer, I see one, you hadn't mentioned yet, there was a question about how to calculate mean rainfall from GPM. That's not one
Yes,
that
I'm not, I said I had to jump back up to the chat. So yes, so the next the next question is, how do you calculate the mean rainfall from GPM? I was just about to get to that.
Okay. I
No
wasn't sure.
problem. No problem.
That's a good question that I can't immediately answer, but we have people on our staff that could. So I invite you to send a question to us. As I said, one of our ways of querying us is using the Earth Data Forum. Maybe you could put that link in too, Jennifer.
Sure, I'd be happy to do that. So I'm going to add the.
You can get our DAC experts, subject matter experts, and members of the general public that might be able to weigh in on that. And like I said, we have expertise in the DAC itself and our DAC, GES DISC, that could address the question on how to do it.
Okay, thank you very much. And I am looking to see.
Can I add one more thing?
Sure, of course.
Real quickly, you can do it with Giovanni. You can select a region with Giovanni and average the rainfall over a period using iMerge data. iMerge data is data from GPM.
Yes, and so I had actually already asked the question regarding Giovanni. There may be another. If you have questions, it would be great if you can enter those into the Q&A. The other participants only the panelists and the hosts can see the questions that are coming into the chat. And so that would be very helpful. So I'm trying to jump between the two. So it might take me a moment to go between those two. So the next question that I have is, let me go down here. If someone wants to study rainfall data, how How do they decide what kind of satellite data is good for respective study? Although we have several satellites, can we go to the high resolution data?
That's a good question. I don't know if other panelists want to weigh in. Anita, can you comment?
So if you need me to reread it,
Yes,
I'm
please,
happy.
could you repeat the
Yes,
question?
of course, of course. So if somebody wants to study, I'm assuming there's maybe a word or two missing. If someone wants to do a study on rainfall data, how do they decide what kind of satellite data is good for this study? Although we have several satellites, can we go to the high? I'm guessing it mean, the question is whether or not there is any high resolution data available for rainfall, rainfall data.
Yeah, so Jim already mentioned that we do have high resolution data, that is GPM IMERS, which is 0.1 degree resolution. But then, we have 3 different products, early, late, and final. So for your research purpose, we generally recommend final, using the final data set, IMERS final. But IMERS early can be used for like quick visualization and just looking at the event for quick visualization purpose only.
Yeah, for spatial resolution, all the iMerge data is 1/10 of a degree.
Okay, thank you very much for the feedback, Benita, and also thank you, Jim. Right. I see another question in the chat. Give me 1 second. Okay, we already actually covered the question about sending your coordinates regarding, let me see. Okay, what is the name of the software that you use for flood analysis? Is it possible to arrange for further lectures on how to use it?
So I used Visual Studio Code, which is running a local Jupyter Notebook server, and that's connected to the base Python kernel that I have. We don't necessarily offer a lot of resources on how to use Jupyter Notebooks themselves, but there's definitely a lot of information in how to set up Jupyter Notebook environments and develop them in things like Visual Studio Code.
Okay, thank you very much, Chris. I appreciate that. The next question is there a GitHub page with resources, for example, Python scripts on how to download GES DISC data? I mean, certainly I can place the link to your tutorials that's on the Goddard DAC main page into as one possible response. You do have command line Jupyter Notebooks for specific products, but I don't know if you have a more like a GitHub landing page that we could share here as well.
Yes, so the response is we do have a GitHub place where we put out our Jupyter notebooks as a guide to the user. So we'll post that link here in the chat.
That would be wonderful. Thank you very, very much. And then at the same time, what I can do is I was just going to post a link to the how-to page within Goddard DAC, because I do think that there's some very useful information in here, and certainly you could filter some of these data recipes based upon iMerge data. So let's see, let me respond here. This is not a GitHub landing page, but Benita, you said you would place that in the chat, or let's see here. I'm trying to see if I've missed any questions. I don't think so. We have talked. All right, nothing else in the Q&A. Okay. Just scrolling through the chat one more time.
Now I can add on our website, if you use the search bar and in the drop-down select how-tos, for example, if you typed in iMerge precipitation, we will return to various documentation on how to access those using different services. And so I can post a link in the chat here, which is the result of that query into that search engine.
Oh, that sounds great. Thank you. I do not see any additional questions at this time. So what I will do is I will thank our speakers, if there are no further questions, for their participation today, and to thank all of you for joining us this afternoon or evening or morning, depending on where you are located. And we'll log off from the audio component, but I will leave the virtual meeting space open just in case you would like to spend a little bit of time on the polling questions. Or if you think of another question, please feel free to enter that into the Q&A. And I will be sharing the Q&A log as well as the chat with our speakers so they can follow up with you offline if you think of something once we have wrapped up here. All right, one more check. I don't see anything else. Thank you so much, everybody. Any final words from our speakers? And if not, we'll go ahead and log off from the audio components and leave the virtual meeting space open, 10 additional minutes.
Thanks, everyone, for attending.
Yep, thanks for having us.
Thanks very much, everybody. Okay.
Bye-bye.
Well, bye-bye. Talk to you later.